Hello? I can't hear you at all.
I can't hear either.
Hi.
I can hear you.
Goodness.
Got
Yes.
So sorry.
Yay.
Okay, it turns out I have fat fingered my own microphone, so that is my bad. Okay, let's start all over again. It's a good thing we're having a little bit of a slow start today. So, okay, you're listening to Interchain FM, a weekly podcast covering all things blockchain interoperability. If you're seeking alpha in the Cosmos ecosystem, look no further than this podcast. I'm your host, Chango Unchained, and today we're here with Ethan and Martin from Confio, which is an engineering agency that builds useful stuff in the Cosmos ecosystem. What useful stuff? Namely CosmWasm and soon to launch Tgrade. That's a shortened version of tardigrade, as I mistakenly talked about on Twitter. So CosmWasm is a smart contracting tool that lets you build cool dApps. Some of you are aware that you can't actually deploy a smart contract on the Cosmos hub like you can do with many of the EVM chains. So it's a bit of a different dynamic here in Cosmos. And CosmWasm is a smart contract framework that lets you do it now, and it lets you write in Rust, and it lets you deploy your own app chain. So some notable projects that are using CosmWasm is Juno that I just launched, Stargaze as well, Secret Network, and very soon Osmosis is going to be following very closely behind. And what that lets these app chains do is do this sort of permission contracting system, smart contracting system that lets you nimbly and seamlessly integrate new features onto the platform, so you could increment new features faster than ever before with this powerful tool. And very soon, Confio is actually launching their own blockchain, which is Tgrade, and we'll talk a lot more about that. So excited to have you both on here right now. Why don't you give us your intros, Ethan and Martin?
Great. Thank you very much. My name's Ethan. I was one of the early engineers at Tendermint All in Bits after Jay and Ethan Buckman. So I'm Ethan Fry. I was Fry for a while, I guess. I was working there in 2017. Worked a whole lot on the back end, worked on the SDK, basically kind of shaped the general design of it back to 0708. Worked on IBC, put a paper out actually back in 2017. I think you published that, Jenko, like in October, November. And I've been here for a while, went off and did a lot of other stuff and worked on Regen, worked on IOV, Starname. And then about 2 years ago, the hackathon, I came together a few other devs. We said, hey, let's build a smart contract engine for a hackathon, 2 days, no problem. And somehow we did that. So big thanks to especially Aaron from Regen Network and Jehan from Altea. That really helped there. And so I carried it on and decided, hey, this is cool. Take a grant to make a prototype, and from the prototype, let's make it real. And it's gone huge, much better than I thought. So it's been an awesome trip.
And this prototype turned into the fourth largest smart contract that's currently being used today, because Terra has forked it, and a lot of other big Cosmos ecosystem projects are soon going to be using it. So it's going to be big.
Yeah. So it actually, Terra's using the same Rust engine we have. They're actually using a slightly, not tip, but like a month ago, version of our Rust platform. Same contract, same everything else, except their Go version is a bit different. The integration is different than ours.
Gotcha.
So a few things work in the runtime, but they're using the same Rust engine.
Powerful. Martin, can you give us your intro?
Yeah, so Martin Warner, work at Confio alongside Ethan, and I come from a capital markets and technology background, which I did for 30 odd years, and then found the blockchain in 2017, 18. And then, like Ethan, worked for a few different projects. We met each other at IOV, Starname, stayed in touch, did a lot of work at evenings and weekends, coming up with these crazy ideas around consensus, around governance, around a whole series of topics. We wrote a lot of papers together, and formally joined together in July of 2020 when we started working on Tgrade and making it all possible through CosmWasm.
Mm-hmm. Can you guys talk more about Tgrade?
Sure. Tgrade is, we sort of came about it, like I say, from a lot of research, a lot of philosophical discussions, I guess, and we were quite keen to use the tech stack that we came up with. And in some ways, a typical blockchain project, that we were a solution looking for a problem. And we spent quite a long time agonizing over that. before we started really looking seriously at DeFi, and figured out that it's really powerful, really innovative with smart contracting. However, it will never be a really big, serious platform for the institutional people, who manage thousands of trillions of dollars every year and in turnover volume, until we sort out some of the regulatory things. So we set to and built frameworks to help institutions come onto blockchain using smart contracts, using governance, and a whole load of exciting tools.
Okay, so you alluded to the regulatory work that you're doing. Can you talk more about that? Just because it is counterintuitive from a DeFi native or a crypto native perspective, but like, what do you see the potential being?
So I mean, the real barrier to me is for regulated institutions. They have to abide by a whole load of laws, some of which are around know your transaction, know your client, and take a lot of steps about checking the origin of funds, which goes against most of what DeFi is for, with a central pool of liquidity, which is global. You don't really ask questions where the source of funds are. You've absolutely no idea why, who the counterpart is, who you're trading, whether it's suitable for them or not. So that is a big blocker for institutions. They are obliged to have in return for having a license, to actually comply with all these rules. So we have to really find a solution for it. We don't want to wait for regulators to tell us what to do on blockchain, but if we start shaping the rules, start making it palatable, looking at equivalence, and put those frameworks in place to demonstrate that we have an orderly house, then we can continue innovating. But we have to bend slightly to the regulations. So the regulations really are around two main, I think, let's call it intent, or it's like the ground principles of regulations are: one is investor protection. So when an investor looks to invest their hard-earned savings, they're not jumping straight into a really toxic binary option or a huge leverage thing they don't understand. So there's a bit of protection there about, what are you investing in? Do you understand the risks? And the second reason is the fair and orderly markets. So they're not very keen, the regulators, on front running, which they managed to stamp out in traditional markets, even though it took them quite a few years to do that. And they don't like spoofing, wash trading, and all the other antics that we see.
What do you imagine their reaction would be once they realize that front running is even more rampant in the DEX space today than what they're used to in the high frequency trading markets today?
It was pretty rampant in the 90s, and they managed to stamp it out. So I'd imagine that they're not particularly supportive of front running, and they probably have good tools to help identify it.
Okay. Well, yeah, this won't be a conversation about flash bots, but we will get back to that later. Ethan, can we talk a little bit about CosmWasm and how that folds into Tgrade, just at a high level?
Definitely. So, I mean, Tgrade's built on CosmWasm. To start the stack is, I feel CosmWasm feels this very, very important niche in Cosmos. I like the modules. I like the design of Cosmos SDK, but it's hard to upgrade. And actually, there's no clear upgrade path. It's usually breaking APIs. Every time the SDK changes, all your modules and your other app have to change. And it's like, and then some people on 36 and 37, 38, some are 40, 42. It's just mess. It's really a lot of work to keep upgrading. And so one thing was, hey, let's make it easy. You write your contract once and it won't change. Your whole runtime can change and evolve and increase, but your contract is the same. So your app code doesn't have to change. And the second was to make it really easy to upgrade. So you don't have to switch a binary out, but we basically, the whole proxy contract, library contract proxy thing they built in Ethereum, so you can switch it out. We built that so you could basically swap out the code on a running contract if you're the admin. So you have basically permission the governance contract, the DAO contract, to be able to switch out the code behind the AMM, right? So, or no one can do it. You make it immutable if you want to, but you're allowed to put that in there. And that's a primitive. So that allows this basically to be much more stable, both in Ethereum, but bring a lot of the features we liked from Ethereum onto Cosmos. So it's kind of this middle ground to give a lot of, it's not quite as fast and loose and just write 3 lines and it works in Ethereum, and maybe there are 5 bugs, but whatever. It's much more of the engineering format from SDK, but it's much more stable. And that was a big thing, stability and upgradability. So we think that's needed for a chain. So when you're building Tgrade, basically, I'm very happy to see all these DeFi spaces in there. We kind of assuming that DeFi would grow to a certain point, and realized it get so big a year ago. We said, hey, the next step beyond DeFi, maybe 2 steps ahead, is regulated markets. You know, they're 1,000 times bigger than the DeFi market can grow to. So we, the idea here was basically to make use of these contracts. We can upgrade stuff. It also allows various institutions to grow their own little circles. So you can have their own clusters, right? So you could have different banks in different countries have their own little clusters, and we don't involve that. It's not us controlling it. They can do it permissionlessly. So that's one of the big things we want to allow with it, right? So different people, we can add some sort of tooling to build regulations. We're not enforcing it on the base level. The base level does not enforce regulations. We provide toolings to let people opt into their regulations. So it's not about us controlling it. It's about people building their own stuff on top, which is very important, very, very important for us. The other key part we did is the same hackathon that I knocked out CosmWasm on that conference, Interchain
Conversations. Interchain Conversations.
That one, Interchain Conversations.
Yeah.
I was presenting a white paper, a very early version of the proof of engagement white paper I wrote with Martin. That was like 2 years ago, a little over 2 years ago. And it was basically trying to go beyond POS and combine POA and POS to avoid a lot of the issues you saw with it. Like, you know, the famous thing with Sunny put 0% commission and came up to like top 1 or 2 validator just by 0 commission attack. The 0% commission attack famous thing. The race to the bottom, the fact that most validators were losing money on it, the bottom 50 at least. And basically becoming a plutocracy. And as you see today, the top 10 validators, I think 7 or 8 of them are either exchanges or hedge funds. And there are 2 of the top 10, I would say, are actually tied to the Cosmos ecosystem, right? I feel like a long time contributors to the Cosmos ecosystem. The top 11 and 20, however, most of those actually I see are people that are long time contributors. They're relatively well-known names in Cosmos ecosystem. So there's still a lot of the top validators are, but the top spots got taken off. And I thought a problem. I saw this as a problem actually back then, 2 years ago. So we started designing proof of engagement to deal with these problems, to deal with that. So we said, and it would, I want to get into that later. I'll get to proof of engagement later. We decided when we built this, actually, we built our entire thing. We haven't released it yet, but we're final testing it internally. We basically replaced the entire proof of stake governance system in Cosmos SDK, pulled it out there, and replaced our own system, which actually built as a series of about 8 different Rust contracts wired together. Our privileged contracts that can actually do things like change the validator set and run begin blockers. So it's a pretty interesting integration. It's not forking WASM. We showed we can do this without forking WASM-D. So no need to fork it for anything really. And we built basically a layer on top of it that uses this and customizes it with all the extension points we have. So we're using CosmWasm to have that, which allows us to upgrade the chain consensus at runtime with a migration code, much like Polkadot claims to be able to do, right? So we don't need to switch out the P2P layer. There's no reason for that live, but we think changing the ruling for how the validator points are given might happen. That's a useful thing to do and can happen actually live.
Okay, let me see if I'm understanding this correctly, which is your proof of engagement logic and validator set changes is done at a governance level, and the P2P stuff is separated from that.
Yeah, so the P2P is still Tendermint. It's all Tendermint, right? The actual low-level stuff is all Tendermint. And it's no. Tendermint is not proof of stake. Tendermint is a consensus engine, which is BFT's consensus algorithm. The proof of stake part on top of that, you have a proof of authority module that's written for the SDK that some people use. There's a proof of stake module. It's like 6 modules. The SDK implements proof of stake on top of it. Tendermint just says, you give me a list of people and their points they have, and I'll make sure that votes happen, right? So it's up to the application to figure out what validators are at what points. So the SDK built this, and there's a proof of authority, but no one is really tempted to replace the proof of stake module in the SDK. It's pretty complex. It's very complex, actually, in the governance system. It was built over a year and a half, back in 2018, 19. It took a while, and so we said, hey, we're crazy enough. I built smart contracts using VM. Let's build our own consensus thing. So we spent like the last 6 months building this with a few devs, and we built, and also decided to build on Rust contracts just for the hell, which was a bit of a challenge, but I think actually made it really nice, upgradable, and gives us some power.
Okay, so proof of engagement is a big thing, right? So how does that work? Like, what does it mean to prove engagement in this definition?
So I would start with it. The way I explain to people understand blockchain is you have proof of authority. You kind of know what that is, right? So a bunch of people have rankings, and maybe they can vote each other in or out, right? So it's a big old, it's basically an oligarchy, if you want to think of it that way. And proof of stake, we know how that works. You basically put your money in and you lock it for 3 weeks or 2 weeks or something, and you get voting power, and you have to pull it out, and you get rewards from it. And that's basically plutocracy. And we see there's bonuses both of them. And if the oligarchy generally is, the people in the beginning at least had the people the vision of the network, right? And the plutocracy, the people that are actually making profit on the network. And there's two different constituencies. Actually, both of them have a voice. Just having the people that are the old timers is a bad decision making. It's really too stagnant. And just having whoever has money is a bit too fluid. So we said, hey, let's combine them. And so what we do is we don't see them as a proof of authority, proof of stake, as a one line. I see it as two axes, right? There's proof of authority and proof of stake. It's two axes. And you can have a different stake and you can have a different authority. And given those two, we can create a function that takes these two inputs and mixes them together. Actually, there's sublinear mixing on it. So at some point, like it tapers off to anti-whale. That is something, again, that was discussed in SDK for a long time. They said they couldn't do it. It's a good idea. They could not do it because you split your stake in two different people and you can't anti-whale them. But because you have the authority points, which are not transferable, you can't do that. So that avoids a lot. It allows us to have sublinear curves, meaning anti-whale things. It allows us to basically say, hey, if you're Binance, you never have zero authority and no one cares what you have done nothing for the ecosystem, you never can have it validated ever. If you contribute a little bit to the ecosystem, you have to put a lot of money to get some points. And if you put a lot for the ecosystem, you put a little bit of money to get some, right? Or less of money. And if you have a lot of voice, like if I'm sitting there and I put no money in, I'll still have no voice either. I have to put money where mouth is as well. So I have to put money in and have time served, both of them together. So that's really the fundamental of it. So you can think of it as, a mixture function. We have proof of authority, proof of stake living next to each other. We put them in a mixture function, mix them out, and feed them into a val set computation. That's exactly how we actually do it with the contracts. Okay. So that's the fundamentals of it. And then the proof of engagement is kind of like, the proof of engagement part is like how we pick the authority, how we decide who's authority. We can get to that later. But first, the fundamental part is just like the mechanics is mixing these two.
Yeah, it makes sense. And I was going to get into the mechanics of how somebody is determined to be an authority. Mm-hmm. So, you said like, time involved in the network or contributions to the network in some way. Can you get more specific about that? So like, how does this mitigate Binance, who has a ton of money, to have zero authority, for example?
Yeah, I mean, they might have some authority, probably not, maybe not zero, but 10, who knows? They might do something. But might give them some for integrating Atom on their exchange, right? So this is a big governance question. So proof of engagement leaves that open question to chain decide how that governance works, right? So is one a mechanics, and it suggests various governance models on top of it. The existence for Tgrade, we have a multi-tier governance system, for example. We have the validator pool, the people who are active validators. So your validator points, you have to have engagement points and authority, a stake, and you self-stake to become a validator, right? And you must run it. So you can have engagement points without having a validator. Doesn't matter, right? The validators who are actually active validators have a voting pool. It's based on who's in the active validator set. That controls things like change upgrades, pinning contracts, adjusting consensus parameters. Everything's operational for the chain. The operations of the chain, they vote on those. They have authority and they can vote on the operational stuff of the chain. We have a second level is we have a community pool. And who votes on that? Whoever has engagement points. So the engagement holders themselves have the community access to the community pool, whether or not the validators. And the block rewards are split between the engagement holders, so they get basically long-term equity payouts, dividends, the validators, and the community pool. So that's how we kind of decide that flow. Then that still begs the question is, who picks the engagement point holders? And so for this, I would say the permissionless model would be say, hey, the engagement holders pick themselves, right? So you just vote on whoever has it, picks the next crew, right? We wanted to keep that a little separate rather than having that difference. And so for Tgrade, we have a thing called Oversight community that is kind of watching them, that can kind of actually have some power over the engagement point holders and the validators. So maybe Martin can get into that deal. And so I would say the first thing I've talked to until now is proof of engagement, right? And this is like the Tgrade version of proof of engagement. So you can actually use, we're going to open source all of this in the next like month or two. And I think proof of engagement as a concept, I'd love to see it used in other chains, or trimmed down version. If you just say, hey, we have authority, we have stake, we mix it together, we have this multi-tier governance system, you can mix and match. The contracts are very flexible to mix and match. You recombine them, you wire them up in Genesis differently, and boom, you have a different version of it. So it's really the idea of mixing them. In Tgrade, are picking this thing called the Oversight community. I'd love to see Martin explain that one.
Yeah, thanks, Ethan. So the idea of the Oversight community was to have a self-sovereign group. And to join the Oversight community, you have to be voted on, you have to put some escrow in, and basically that forms a group. And then they must listen to the community to steer, really to gain consensus from the community itself as to what is engagement. So engagement's a bit very easy to understand, but quite a broad definition of what is engagement in the chain. So part of the concept in Tgrade is we took a big step back when we were designing this and said, well, actually, running a blockchain isn't just a matter of 100 odd people running data centers and running validators and getting paid for it. There's a wider community around that, and we see that with other chains, that there's contributors who blog, that evangelize, that help others, and so on. And they don't naturally get rewarded, but we wanted to really build this collaborative model. So we wanted to create the incentive to collaborate, i.e., get involved in the chain around running the chain, not just providing the validation services. That is an important role, but equally, we wanted to give out rewards to other people. So that's what the self-sovereign group does. They sort of have the ear to the ground to figure out who's doing what. There'll be a dialogue with the community to figure out, what's the important step in the course of Tgrade. What's important now for engagement might not be the same in 6 months, in 12 months, in 3 years. It's a moving feast that is decided with the community, and they have the tools to be able to allocate out these engagement points. Now, if they go rogue, then people can join it and start kicking out people if they don't like them. And there's degrees of punishment that these people of the oversight community can be slashed or can be completely kicked out. So there are sort of degrees of punishment in there as well as carrots. The people on the oversight community, in recognition of the time they spend, they automatically get a set amount of rewards. I guess that changes with sort of normal constitutional ways of changing that if the token really starts moving differently to, from 1 year to the next. It's important they don't allocate the pay for themselves, because that really gives an incentive for it to go rogue. So we decided that would be better as a flat fee. So backed up, or this is all backed up by a constitution. We spent quite some time actually writing down a constitution that goes alongside this to define under whose authority this group works, how it works, what the rights are, what the actors are, and really want to create that as a living document as well. And the constitution's been translated into Russian, French, Vietnamese, I think Chinese as well, to try and make it as inclusive as we possibly can. So it's not just a European perspective on what the norms of the constitution are, but to encourage everyone to have that input. This is a global project, and we don't have all the answers. So that's why we really encourage the democratic process alongside the tools that we've got for collaboration.
You guys have really thought more about the governance process of this protocol than a lot of other projects have. But I wouldn't necessarily consider you a governance project. But what's the long-term vision that you have for this project? Is it that its primary focus is going to be the sort of democratic on-chain system that allows for institutions to arise and utilize it? Or what's the kind of I don't know, tagline that you have for Tgrade?
Well, the background to all the governance and why that's really important is that if we're going to reach out to institutions and they're going to put billions, maybe trillions of dollars worth of stuff on the chain over the next 5-10 years, they need to be really convinced that what we've got is secure. And if we can demonstrate that we've got really good governance, it's decentralized, there's a constitution, we've really thought through all of these things, that It's not suddenly going to be down to 5 anonymous validators running the network and no one knows who they are. But we've got these checks and balances in place. That gives them the security. And when they're going to have conversations with regulators that we want to put our value or issue large amounts of financial institutions on Tgrade, it ticks all those boxes. The questions are, who runs this network? Well, it's decentralized. It's got this governance. It's very easy for them to explain that and to make it obvious that what they're doing is putting their money onto a very secure blockchain effectively. So that's why we really focused in the early days on the governance side of things.
So I want to add to the governance point because I think the governance aspect of Tgrade follows a lot from I had discussions with Martin, so we resonated here, but desire for governance, good governance. It's something I've been into since 2008, maybe, 2005. Is basically from self-organized autonomous groups. Like if you have volunteer groups, NGOs, trying not to be hardcore models, how do you build that out? How do you get 10, 20 people to collaborate? If you have an eco-village, how do you have a bunch of people living together out with a clear leader? And you see what happens when you have leaders. You see what happens when you have bad dynamics. I worked in different offices and we had different versions of Scrum and try self-organize stuff and how that works and how that fails. And when he started doing Cosmos, I said, okay, what's a governance model? Okay, validators vote, and that's it. Kind of, I'm like, but it's just, it needs to be inclusive. You need to have, it's not just voting power, it's the whole process of how do ideas form? What communication forms do we have to bring ideas in the forefront? How do you poll? How do you reflect the community? Not just like, majority rules, right? Majority rules can work very well, actually, in a very good environment, right? Or maybe you need full supermajority rules, who knows? You can see that majority rules breaks down. The US has become a hostile environment. You have like me or you, and basically it's a complete breakdown of democracy, not because the rules are bad. They're very similar rules they have in other countries, but because the parties are broken down, right? And in the same country, the same rules, you'll see, like in Germany, for some years it was working well, then basically it's splintering, and then it's like becoming more and more dysfunctional, not because of the rules, but because of the process and the way people approach each other. Okay, this party here, no one talks to them. This party, no one talks to them. Just us. Oh, we don't like each other either. So how are we going to work together? Because if people can't compromise and work together, you cannot run governance. So the human aspect of governance really attracted me for a long time. And blockchain impressed me because at the end, human governance is always, there's someone that had the admin key, right? Someone always had after the checkbook, someone had this thing. And it was always the loose thing that you had a governance process, but there's always other people with the physical power. So with a blockchain, I said, wow, this is amazing. You can actually have a bank account that no one can steal, right? You have to all vote for it to move the money. And then it was, okay, you can make these rules. I think these voting rules are nice. And so one is, how do you distribute the votes? Is it just who puts more money in? Or do you have like the engagement two-dimensional thing? And the second is, what are the processes you use in order to to come to agreement? And all these off-chain tools. So yeah, I was sitting there with Gautier in 2017, also designing governance processes, which were kind of, I felt, just dismissed as unneeded. I looked at Aragon a lot. I thought it was a really interesting project. It seems to have fallen apart a bit. And I look at what Commonwealth, actually what Osmosis does for Commonwealth, discuss stuff. I found that really cool. Like they're using this tool, and I think it's not perfect, but I think it's a great step forward to really encourage discussion. And I think I felt very promising to see this in use again. And like these ideas I felt as ignored, like the human element of coming to decision-making, of argumentation, of having multiple points of view, which are discussed and come to an agreement that's actually not me or you, but me and you, and something better than either one of us comes up with. I think it's super important to any project that actually wants long-term viability. Yeah, so that's maybe my rant about governance. But I think it's a super important thing that's overlooked. It's not just about saying, give it to the token holders and majority rules, and why are only 15% of people showing up to vote?
Yeah, sure. And we have seen that majority rules doesn't necessarily work, right? There was an experiment in Athenian democracy where they had direct democracy. They used, what was it, shells or something to vote. Every single individual voted, and it was like whoever voted, whatever was majority, that was the decision. And we saw that really broke down. So I totally understand the system of checks and balances that's needed for a healthy system. But what do you think failed about Aragon? Like, what was interesting there, but ultimately caused it to fail? And what's interesting about, I guess, Polkadot governance or lack thereof, or and Ethereum as well, or Bitcoin? Just wanting to compare notes.
So I'll say I brought in May 2017 when we had our first retreat in Cosmos. I brought in a friend of mine in to discuss about the governance issue. Right, he had expert actually in agile and sociocracy and various organizational mechanics. And he came in there and he came in and basically said, you have to reproduce the governance system you want to produce on chain. You have to produce in your company as well. And his point there was basically that it was an authoritarian government of J. And you had to change that completely in order to have a democratic governance on the chain. You will not be able to produce a proper inclusive democracy if you don't have inclusive voices in the company itself. Of course, it didn't get anywhere, and I think the same thing happened to Aragon a bit, right? It was like this build whole DAO, and in the end, a lot of the critique of it, what came apart was there's actually like a few founders that were controlling it that became out of sync with the community and infighting. And so at some point, like there's kind of this community, and as long as everyone's in sync together and the founders are controlling everything, but they're kind of doing the same thing everyone else wants to do, no one really complains about it. But if they have all the power and suddenly they go different directions, you have the explosion, right? And it clears out that, hey, we have authoritarian governance here. We can't do that. And it kind of fell apart. I think because I'm an outsider, so, don't attack me too hard if that's wrong. But it sounded like from the outside, it was like a few people make decisions, a lot of people complaining about it. And it was like not a general group of like hundreds of people coming to consensus, which is what they're building, actually, software they're building, which was supposed to do. Bitcoin is very interesting. It doesn't really move anywhere because there's so many parties and no one can control it, which is kind of awesome. I think Bitcoin, I used to kind of be like, oh, Bitcoin's old. And actually, it's like that, old pickup truck, that Ford pickup truck from the, 70s or 50s. It just never dies. You can fix the parts that, nothing will break it. It'll keep going forever. It might not go the fastest or the strongest. It might have really burn gas like crazy, but it will never die, right? No one can stop it.
Even during an apocalypse, you could rely on it. Gas in it, yeah.
Everyone's fighting. The miners get banned in China, and 3 companies are trying to take it over, and it just won't die, right? So I think it kind of has this, not on chain. It goes slowly, but it requires such a coordination of so many different actors to have anything happen there. You kind of, you can fork and go off and you're dismissed most of the time, right? But you really have to coordinate the users, the miners, the exchanges, the devs. You have so many, and if you can coordinate them all, you get to move forward. So it's a very conservative thing. So it's not great for fast decision making, but it is able to maintain a status quo and be pretty resistant to attack, which is the exact opposite. But Aragon is going quite fast, but it was quite easy for a takeover because there's really a few people controlling it. Polkadot, I think, is similar in a way. I think basically it's Gavin Wood project, as far as I'm concerned. Maybe he has buddies in there. It's a few of them, and it's really led, and which is I'm not going to criticize it in a way that I think it's efficient. I think the decisions they're making are good. They're not exploded or anything. So, but it is really led. I think some of these projects need to really, at early stage, you need to have a strong leader that gives vision, that gives direction. And I believe strongly in progressive decentralization, which is you start a project with a small group which is committed and they maintain the power. They don't just give it to everyone right away, right? It doesn't work this way. I've tried it. And slowly you grow it up. People come in and you give them a little more and get involved, and the more people involved, and you decentralize. You have to have it. It's hard to do because you have to have someone willing to hold power in the beginning and then give it up to the community and step back. And it's a really hard place. It's much harder to do.
That's a really rare attribute to find in individuals, especially people who want control or enjoy the power. They want to hold on to the power. But then eventually what's ultimately good for the ecosystem is to pass the torch on to new blood.
Yeah, and we've seen that in DeFi protocols almost force their hand because effectively core devs kind of control other ones, right? They control the updates to it, but they realize they cannot control the multisig. So most DeFi protocols start with a multisig of 3 or 5 people from the core team that can update the protocol. But as they grow and suddenly there are hundreds of millions or billions locked in there, no one trusts those 3 devs with that much money. So they have to make governance tokens. They have to give it, decentralize it, and have to have control to, hey, the keys to actually change the protocol, maybe not everything, but at least the keys to change the protocol, we have to give to you guys because who else can we trust with those keys? Right? There's no other approach to give some of those keys that we don't trust they're going to run off with all the money in the contract. So I think their hand is almost forced in that case. It's actually cool to see it. I think there are better ways of organizing. A lot of these governance tokens and DAOs that are built around the DeFi protocols could be much better organized and much more inclusive and much more progressive. That I think they're kind of conservative in the way Bitcoin's conservative. It does not change. Conservative not meaning liberal conservative, but meaning it maintains the status quo, right? It's hard to change, innovate. But that's good. If it's big, it's strong, you don't want to mess up. You want to be careful. You want to take slow steps. Once you have lots of money in something, you don't change it, move fast and break things doesn't work when you can lose billions. So I think it's almost forced the hand. I think it's actually a cool thing in DeFi. So hopefully that will happen in more projects.
For DeFi protocols, certainly. But what about for layer ones? Let's look at Solana and Avalanche for a little while. They're sort of structured in a similar way as Polkadot in that it's kind of the center of gravity is the personality of the founders, right? Very strong personalities. Where did layer ones go from there? Do you think they are going to suddenly give up their treasury of their foundation and then offer it up to the community to just do what it wants with it? Or how does that play out, right? These are the most relevant layer ones right now.
Bitcoin definitely is different. Ethereum kind of shows an example, maybe of where it could go, maybe, right? There's Ethereum Foundation, but a lot of other companies took over places. It was also not strong hand, so a lot of other early on, like Consensus had a very strong, direction to it. Really felt a lot, and there's other projects built out and they started having strong pushes onto it. There's minor groups, so it kind of started having multiple interests. I think these larger projects like Avalanche, like Solana, like Polkadot, they're still relatively young in Ethereum terms, right? They've had mainnet maybe a year ago ish, right? I think it's still good to have a strong founder giving strong direction and still fixing bugs, because what happens if you have no founder, it kind of flounders a bit. So I don't know where they go. Honestly, I hope they go somewhere like Ethereum does, which is more and more decentralized de facto, right? Like they don't have that. Some of the founders went off to their own projects. Vitalik kind of stepped back. He's kind of this, it gives the vision to Ethereum, but he can't control anything day to day. But it also slower pace. Ethereum moves at a slower pace, right? Which is more conservative. So it says the layer one's not developing, the other stuff on top of it is. So I hope these things stabilize at some point, are able to devolve power. But maybe they stay that way. Maybe they stay with one person. I think that's actually a shame in decentralization. So if you have a protocol that, in theory, it's fully decentralized because all the validators are fully decentralized, right? Like you have a bunch of people using it, running it, but basically the only direction happens is one guy says do something, I'll do it, right? And like whoever says no. I think it's kind of cool in Osmosis. They said they're complaining that they proposed something, an upgrade, and the community voted against it. I was like, that's awesome. The core devs proposed something and the community voted against it. It said, no, try a different thing. We're not doing the upgrade. So that was actually, for me, I talked to them like, that's a cool sign you did that, right? They were a bit annoyed, but I said, that's cool. That's cool. It is active government. There is actually pushback. It's not just, yes, we follow you. So I think it needs to have, at some point, you say, yes, we let the founders do this stuff. At some point, you say, hey, guys, we're checking you. And I don't know when that happens.
Yeah, sure. So I want to go back to CosmWasm a little bit and talk about the implications for developers when it comes to interchain composability and upgradability, right? Like what can people do with it? This is very exciting stuff. And I particularly want to focus on IBC contracts because that's particularly powerful. Can you talk about that?
Awesome. Thank you. I love it. It's basically, if I could do nothing else next year, I would just do IBC contracts, honestly.
All right. Like what is it? How do people use it? What's good for?
So let's imagine if the IBC is super powerful, like the concept, like ICS 20, which is move token across chains. I was writing this down in 2017. And so like we could have had that years ago. What they've done actually, and so I respect, I'm not criticizing, what they did, Chris Go and the Agoric team and that stuff did is they built this huge composable thing and say basically the connections. What I designed as IBC was back in 2017 was basically ICS 20 only. You have the whole thing hard coded. You have one channel, one connection between two blockchains that was both the client was a channel. There's only one port. Like it's all one line. All you could do is move tokens, nothing else. And they have a composable thing. So first you have this thing you can the light client proofs move on one level. Then you have multiple ports, multiple applications listening, and they can connect one application to another application over here. Right? So like you'll have multiple connections and between them, they have different channels. You can actually have multiple channels between two applications or each application can have multiple connections. That is super fluid, which means with that, and the relayers can understand all that. The relayers are built to handle anything, these packets. So at this point you say, okay, we have the ICS 20 port talking ICS 20 port. Okay. That's the thing. We have we have internet, but all we have is mail servers, nothing else. There's nothing else. right? You're like,
And
that's kind of
ICS20
boring.
would be the interchain standard equivalent of the ERC20, right? So in theory, if we had Ethereum run ICS20 standard as well as Cosmos Hub, then they could just transfer fungible tokens across one another, and that's the idea, right?
Totally, totally. It moves
Okay,
fungible tokens.
right. So that was
So
your version, like IBC v1.
yeah, that was the idea. And so this is all they've built now. So they have this huge and only thing built on top, only application level is this. So all the work is done here, and they have one thin application level. So you want to add other ones. There are lots of talks of adding things, interchain accounts. So I can have one contract here control another contract here. I can stake, I have a proxy account here I can stake on. What you could do on the hub, for example. So like I could send, atoms to a contract over here. They'll send it back to the hub and they'll stake them on behalf of you and issue staking derivatives on another chain, for example, right? That's the idea of interchain accounts. NFT transfers, another concept, which is not much different. Then we extend it. And so the problem with this is to make an IBC upgrade, you need to install a protocol on one side. It's useless on one chain until the other side installs the same protocol on the other side. They both install it, then you test it out and you see it works and you build products on top of it. It's a very slow process. IBC contracts are you can create a contract that handles IBC. It creates its own channels, it creates its own packets. Not just using ICS20, you create your own protocol. Right? So I've written a contract that speaks ICS20 to ICS20. I've written another pair of contracts that talk their own protocol between each other. And it was interchain accounts. And this was done 10 months ago. But it only works in two CosmWasm chains. You install interchain account listener and an interchain account server, a client and a server. And this one connects here. It makes an account for every different connection. And you run that on there. It works in any two CosmWasm chains.
Yep.
And so I think it's cool, and I can deploy it. And as soon, actually now that if another mainnet is up there, we can deploy, Tgrade and Juno can deploy this and start talking to each other with this already. And if I have a better idea, I deploy it on both of them and it starts working. Like I can permissionlessly deploy this and within a few hours, I have a new protocol running between two of them. In particular, I want to give one example. I'm talking with Osmosis to add, so the DEX Osmosis is really powerful. What really more awesome is if you can compose it, interchain composability. Right? So imagine DeFi. What makes DeFi awesome on Ethereum is composability, right? So like you have an AMM, and that's nice, right? And you use it, and you have this lending protocol. Well, the lending protocol can look at AMM to query the actual average price of the last 2 hours of this pair. And if it needs to liquidate, it can liquidate on the AMM, which is awesome. Balancer AMM says, hey, we have all these tokens you don't need. We can put half of the pool of liquidity as an asset manager, which then feeds in to the lending protocol to get returns on this stuff. So they actually go back and forth. It's a two-way street here. It's a pretty awesome thing how Balancer and Aave are working on the asset manager stuff. It's amazing composition here. I said, let's do this. Osmosis is Balancer. It's a Balancer. It works, right? But we said, let's do this. So I'm actually working with them to develop a protocol, and we want to deploy this hopefully in a few months, which will allow another one to swap. It'll be atomic. I transfer tokens, I swap them, and I return the swapped tokens. Or I can't get the price changed too much, or front run, and it returns it fails. I get my original tokens back. Not as a 5-step transaction, it was an atomic transaction. And so I always talk about deploying that as CosmWasm contracts on both sides. And then, hey, well, maybe I can make it a native binding for you. And they're actually talking about adding permission CosmWasm to allow things like this to deploy quickly, so they can quickly add their half of it, of this thing, is the server side of it that's bound to their contracts. They can do the swaps, and then have the client side another one. So I would imagine having a lending protocol like Aave on another chain that would be able to swap on Osmosis, use Osmosis DEX. Now imagine that we add another protocol that says, okay, let's add another protocol, which is a lending protocol. So this chain deploys a new protocol, so then Osmosis can now add one. So it can say, oh, I want to invest my tokens here, invest token here, right? Invest back. And maybe it's a customization of interchain accounts. Maybe it's its own protocol similar to that. But we build that protocol. You build another one. And you can build lots of them. It's not limited. I would say it's more complex than calling directly. But it's not as hard to build a new protocol as it is to, build a whole lending protocol or a whole AMM. That's more complex. The whole Osmosis is much more complex than building a new IBC protocol, because we're just talking about the top level, the app level of it. So I think those are things that, I'm talking with Osmosis about doing. Hopefully have that in a few months, find a partnership and actually get forward with this. So And I think that'd be really awesome for the whole ecosystem to be able to do that. So we can basically say, hey, these 3 chains do DEXs, these 3 chains do lending protocols, these chains do something else. They combine this way. We have a stable coin over here, and we can, and then someone builds, whatever, Alchemix on top of it, and that just, ties 3 chains together. And it doesn't matter where you live, and you don't just have to move tokens. You can actually have full DeFi composability over 4 different chains. I think it would be mind-boggling when that happens.
Yeah, so this is really going to open up a wide it's going to open up an explosion of DeFi apps. So what I envision happening is something like specialization, right? Like the vision of Cosmos where each app chain is kind of specialized for its own niche. So if one app chain is good for NFTs, it does NFTs only. And then if it's CosmWasm enabled with, let's say ICS 20 or ICS 721, right? The equivalent of ERC 721, it could then send fractionalized versions of NFTs to Osmosis, for example, and then I don't know, sell NFTs off of it. And then, you could use the collateral, you could use the NFT on your chain, collateralize it on the Aave chain or whatever, create a fractionalized NFT, loan it out on the whatever lending platform, Umi, for example, and then do all this stuff. Like basically have the same power of composability that you have on Ethereum smart contracts today, but cross-chain in a really powerful way, using this sort of lightweight CosmWasm layer on top of each chain. Is that right?
Yeah, and exactly. So a lot of people talk about multi-chain, and what they do is they have a client UI, and the UI says, you as a user, move your NFT over here, use user, do this thing. And so it's all the client side. This is server side. So it's not just, which is powerful, means a contract over here can then invest over here, and the contract over there can invest over there and do this thing. And yes, the point for CosmWasm is the only way I see to get these protocol updates in a reasonable time is CosmWasm. Because otherwise you're waiting 4 or 6 months per chain, and there's no point for me upgrading until you upgrade, and then you upgrade to me upgrading, right. And each upgrade itself takes 3 months.
SDK.
And it's already 3 months to any upgrade happening for one chain. And then if you have 2 chains to kind of coordinate a collective upgrade between them, and you're like, product roadmap depends on these 3 other chains doing an upgrade, and I'm never going to upgrade. So it's just, trying to coordinate 4 different chains product roadmaps together to make a product is just not going to happen. So CosmWasm said, hey, we put this little app, all it does is, it talks to them and it sends a thing to you, and it calls into your native code. So yeah, I think that's going to be the way the IBC will happen. And I think once these protocols are established, they will be coded in native Go. There'll be modules. They'll be updated. Some chains will not want CosmWasm, which is fine. And these ones will say, hey, we've established 2 or 3 different protocols. You can implement that protocol in native Go. You can employ it next chain upgrade. And when you do your one chain upgrade, suddenly you have 3 chains you can already talk to because they're running the CosmWasm version of it. And maybe these will ossify not being a bad way, but turn solid, and go from being very fluid and being more solid. And maybe them all eventually the good ones will turn to Go modules maybe and be everywhere. But I think it's a great way to experiment and build out new IBC protocols.
Yeah, and this is really powerful stuff. So if we're going to have Ethereum-like composability between smart contracts, or in our case, app chains, we have to talk about reentrancy. So in your Cosmoverse talk, you talked about reentrancy mitigation. How does that happen through CosmWasm contracts?
Yeah, basically you have to store your state. What reentrancy happens is this: you have, let me give an example of reentrancy, right? You have a contract that understands one thing. It will have a process basically, okay, I hear a doorbell, I go to the door, I answer a door, I get the packet, right? And I check, I pay out the money, right? Basically on this thing. I go through there and I go then make a phone call. After making a phone call, I come back and I pay out the money, right? I check to see if I have the money in the bank account and I pay the money. Then the phone call though is actually called on the contract. It might be malicious. That phone call, while you do the phone call, you stop, another ding dong happens. The other ding dong comes in with another person sending the packet to you. You make the same thing, but because you kind of forget what you're doing and you lose that, you haven't actually stored the state. You're actually looking at your old balance, and maybe they send the same packet 5 times. You say, oh, this is a new packet. Oh, this is a new packet. This is a new packet. And you evaluate every time the new packet, you haven't seen it yet. And then you pay them every time because you haven't realized it. Because there's state in memory, and when you call back, you call out someone else, they call back into you, and you have this state in memory, which is different than state on disk. And so you're seeing different snapshots, right, on top of each other. What we do in CosmWasm is we don't allow you to call the contracts directly. is the actor model, which is proven like it's a long-term thing for resilient software that avoids a lot of these problems, both multi-threaded issues and reentrancy attacks. That you run your state, you finish your state, you store your state locally, and then you say, I want to do these 3 messages, send them off to other people. Eventually they might send you other messages back and then run them, but they run them in order. And a scheduler just handles them. But so you finish your job and then you say something else. The other person finishes their job, it gives you something else, right? And so in this story in the story, the guy ding dong, you make a phone call. The phone call says, okay, I want to do this thing. I get a note, do something, right? You pay the person, you check your balance sheet that you've actually paid this person for this invoice. And then you say, hey guys, I'll do this later. I have a to-do note for something else to happen. That one will trigger something else. That might trigger another ding dong. When the ding dong comes back, the second time comes to your door, right? You actually check your state. Hey, I've already seen this packet because it's written down now. I finished my job. I completely finished my job. I save all state to disk. There's nothing in memory. And then someone comes back again and it's not reentrancy. It's just like 2 sequential calls to me, which is different than coming and tricking me in the middle of an action. So it avoids a lot of those, avoids a lot of other things. There's a whole list of these things in Ethereum. We looked at them. Ethereum did a great job in the beginning. They're really flexible, really powerful. And they were not really expecting the surface area they opened up. They put a huge attack surface area. So we limited a lot of things they did. We say this is not, it changes developer style, doesn't prevent what you can do, your potential, it prevents style. But it allows you to have much more safe contracts. So I think Ethereum allows you to write contracts much easier to get something working, but it's gonna be buggy. There's attack vectors, there's so many attack vectors, and you need to pay a super expert 100,000 to make sure it's safe. And otherwise you can't deploy stuff. And CosmWasm, the Rust compiler bigs your head, you got some unit tests on it, and pretty much if you've covered your business logic, there are a few checks you want to do to make sure you do some validation logic, obviously, like some validation stuff on it. But pretty much you're safe, right? There's some issues, but you don't have all these super tricky little issues about gas pricing and reentrancy and callbacks and these things. It's all these little tricks in Ethereum. It's really hard. And so I say the distance between, Ethereum is easy to write, but really hard to write secure. And CosmWasm is harder to write, but the difference between writing CosmWasm and writing secure CosmWasm isn't very much. So the Rust compiler is your enemy at the beginning, and when you want to make it secure, it's your friend because it caught all those bugs.
Okay, yeah. So CosmWasm is dummy-proof smart contracts.
Well, kind of. It's a bar to enter. It's a high bar to entry, but once you've done it, it will it's much harder to shoot yourself in the foot. Well,
relative to the Cosmos SDK, how high of an entry is that?
I thought it'd be really high because it's Rust, right? And people say Go is much easier. We use a small subset of Rust. So a number of people have learned Rust using CosmWasm, and they say it's actually much easier than learning, Rust with async and all these complex things. We limit and simplify the API to be relatively simple Rust, I would say. So if you've used Go, it's not that hard to learn. The compiler will yell at you a lot in the beginning, but then it's not that many things to learn. I thought it'd be much harder, and people come from Solidity complain a lot, but they'd complain with SDK. Their mind would be blown with SDK, honestly, the complexity. And a number of people have moved to SDK, so it's much easier, actually, because the complexity is limited. We give you a little box. You don't have to wire everything, and there's so many APIs and so much conceptual understanding to write an SDK module. It's powerful, super powerful. We say, no, we give you these pieces, and this is what you can do. And you can accomplish 95% of the things you can do with SDK module in this framework, but it's much smaller. It's a clear surface area. It's documented, and only these points you have access to. So by limiting it, make a very clear API, and we say you can do most things. And the advanced things, some of them are more tricky to do. The advanced cases, and some can't be done. But we say the most simple things, or most typical things, I'd say, can be done quite quickly.
And how does this compare to Substrate?
It's different. So people compare to Substrate. I thought it was almost unfair comparison. So Substrate is like the SDK, right? And CosmWasm took the position of we're like contracting language for them, or like Solidity at first. So I think it's probably the most powerful contracting language out there, right? People. I just saw a quote the other day on Discord. Someone asked who wants to help me write a CosmWasm emulator for Solana? Solana contracts are really a pain to write, so let's write CosmWasm contracts on Solana, right? Port them to Solana, which was I love that, right? Okay, we built a nice design language because they're I can't do these Rust things on Solana. So Solana is faster. They do some things for optimization, but it is a really hard API. It's a really hard API. It's trying to just focus on speed, and we should focus on dev usability. I think Substrate is also powerful Rust. It's also very complex. I've seen code there. It's just like this API surface area is huge, and when you get to know it, it can do lots of cool things. I'm not criticizing it, but it's like the SDK, another huge thing, right? I think it's somehow clean in the SDK in terms of the design. They iterated a few more times on it before they launched it, but it's still a very, very large surface area. Lots of things, lots of magic. Macro happens here, macro happens there, and the very types. And it's like, so you say, let's make it simple. Make it simple. So it's again, it's a native thing, so you can do more things. You can run a consensus engine at P2P level and Substrate, but no one's really writing those palettes. If you're writing app palettes like a DEX, if you're writing a lending protocol, if you're writing an NFT platform, if you're writing a governance system, if you're writing your social network even, right? You're not using these, you not need to customize a consensus engine in that P2P layer. So like, you don't really need that. So the API you want for business logic should be small. I'll also say that we are working, again, we've picked this up. We got a partner, Shane, helping us now on this one, pick this project up and working with them on Go CosmWasm contracts. It will allow you to compile Go code into CosmWasm using TinyGo. So I had a prototype, internal prototype of this, and we are picking it up again. So let's see how far that goes, but we may have that in some months.
Okay, exciting. Apples to apples comparison, how does it compare to Agoric in this case?
So Agoric's big thing is easy because it's JavaScript, right? And it is. The code is not hard, but I can read JavaScript. I write JavaScript. I wrote the TS Relay in TypeScript. I've worked on CosmJS before. Like I've written React apps some. I'm not the best designer, but I can use. I'm not ignorant. I have a brain when I look at their code because the conceptual model is super complex. It's not bad. It's good. It's probably better. It's just I feel stupid looking at their thing because I haven't figured out. Like I saw the example of how to trade things, but where the trade happening, and there's this complex thing of passing these permissions and capabilities and something, and like this is, I don't know. I probably need to sit through several lectures on the conceptual model of it, right? Where I think, and it may be more powerful, but I felt that is a huge part of entry, not the code itself. The code's clean, it's solid. I've seen examples of it's simple JavaScript, it looks great, but I could not figure out the conceptual model of it. And
right,
maybe it's me, maybe it's their description, but yeah, it's a pretty tricky conceptual model.
Right, understood. Okay, so yeah, we're coming up on the hour mark, so we just want to cover really quickly on a high level, what sorts of business applications could people use with the tools that you've presented today?
Cool. So I'll just maybe go over to Martin a little bit, but so what we've built already and an example code we've handed out in CosmWasm Plus already governance code, lots of governance code, groups contracts, subkeys, governance code, we inspired by that stuff. We've handed out a lot of NFTs and tokens, CB20 token, escrow, stuff like that, staking derivatives. People have built DEXs, lending protocols on already. They're building NFT platforms. Anything in the DeFi space you think of Ethereum, people have built. We've built out powerful governance tools. PoE is also a consensus engine built in that, as well as governance layer on that already. And we've built trusted circles, which are kind of like our DAO++, our Aragon version on it. So all these things you can think of in those spaces we've built already, including low-level things like consensus. And I think Martin might want to give a fee of some things we could build in the future. Like I talked about interchain composability and how to bring DeFi composability, which I think is a huge thing to build. And I think Martin might talk a bit about what we could build in terms of other apps.
Yeah, there's a whole list of companies I'm talking to, institutions, startups, whatever. They're very excited about this space, about using the trusted circles. There's I think a lot you can do with smart contracts and finance. The financial engineering, I think, is been shown in DeFi what you can do, but there's so much more you can do. So I'll give you a very quick example of a blog I wrote a little while ago called multi-programmable multi-dimensional instruments, basically. So what the concept there is, you take something as standard as a corporate bond, 10-year life cycle with a regular coupon thing, set out the whole schedule. Then the interesting thing part is added on top of that. So you start bringing in things like social impact measurements, where you can say that if you achieve something during the lifetime of your bond, say in an example, if you're selling cars, you sold the majority of your cars to a car sharing pool, you get social credits for that because there's less cars going around cities. these things are measurable. You can use that in a smart contract. You can say, well, I'm going to audit the data, use signing, and create these things that attach to a standard corporate bond. You do the same with environmental impact and say, look, I'm using most of my power from renewable sources. I've cut it down through whatever measurements. Again, it's measurable, transparent data you can attach with a financial instrument. I think that's where the real power of this stuff's going to come from.
Yeah, do you expect this sort of suite of apps to be hosted on Tgrade, similarly to the EVM being like a generalized virtual machine that's shared by everyone?
Absolutely. I think what we've done is create the nice framework, the basic hygiene for institutions to come on. And then what happens next is where the real excitement begins. People building real businesses with real use cases.
Very exciting.
So I think ESG use case can be DeFi as well. So you can have staking derivatives that have environmental things. So if you're staking with the environmental hosted one, you get some e-credits, and you stake with the one that's just like using coal power plants, you don't. And so you can combine these on some other ways too. So I think these are powerful ideas. I think the ESG thing is really, really powerful.
Yeah, the thing about environmental credits is that like once you have partnerships with I guess the IRS or the government's I mean like the IRS, right? What I'm trying to get at is once people can deduct these from their taxes, that's really when this becomes applicable, right? So powerful. Yeah, I mean, my head's just on taxes right now, just because it's the year end. So anyway, okay, there's one last thing that I want to touch on, which is DAO, right? So their interchain DAO on Juno uses CosmWasm. Just like lightly touch on that because that seems like a cool application that's just burgeoning.
Yeah, I think it's kind of the new Aragon in a way. So I built a lot of this based on these contracts throughout like a year ago. I said, hey, you can build a group and you can build this DAO on it, and it can be staking based, and you can build your own token, and it kind of like had this prototype out there in CW Plus. It was very generic and had no real UI for it. And I founded them. We built the Interwasm DAO. So basically, CosmWasm funding has been kind of interchain for a bit, and then get off the ground. And then we started funding it through Tgrade, and all these other projects are making lots off it, right? And they haven't really contributed much. So say, hey, we can't keep taking all the burden of building all the software, doing support, building all the examples, doing everything for it, building all the tooling around it, and you guys are making all the money and doing nothing, right? So hey, let's build this thing. The core engineering we maintain, but all those things building like IDEs, Etherscan, everything else you want on top, let's do it. So we built Interwasm DAO. A lot of chains should be donating to it, and they can do public good funding that supports all the CosmWasm community. And we looked for hosts for that. Say, hey, let's build an actual DAO for it. And we found these people actually are building these DAO on Juno. So great, we'll just use your software. And it's general DAO software. The idea is like Aragon in a way. They have this open source DAO software. I've seen some previews of their apps. It's pretty cool. Basically, it's you can multi-sigs, you can stake tokens on it, you can get these tokens off it, and you can create things like, hey, let's vote on sending money here. Let's vote on investing the money here. So it's using the power there. Right now, unfortunately, some JSON in the UI when you're constructing messages. That said, it's easier to have they have a JSON builder they're working on to kind of build these things. But it's still better. Currently, the way you make a governance contract in the Cosmos SDK is composing lots of command line arguments and sometimes JSON blobs and lots of command line arguments and passing files over Telegram or Signal and then combining them. And it's like this, experienced developers take an hour to figure out what they're doing again, how to use it. And this is really a very simple way of doing that to allow multi-sig. So I think it's very, very powerful. I think it will evolve, and it's pretty cool because it's not really a clear entity or funding behind it. It's kind of like a bunch of people, such as the Juno and Stargaze, a few other people involved in it, and everything that kind of wants to build DAOs is kind of coming into it. So I think it's really cool because they're actually kind of autonomous, and they're talking about their own DAO to get funding from other people, like Awesome DAO. So let's make a DAO and get funding from all the CosmWasm chains to build this. Now let's make a DAO and get funding from other people to build DAO software for other DAOs. So I think it's really cool because it starts off in this really collaborative, really decentralized way. So I think it might have a huge potential because they have to eat their own dog food from day one. So if it goes further, it will actually be decentralized because they never had a centralized figure leading it.
A DAO to build DAOs for future DAOs. Okay, all right. So we're going to take one question from the live stream. I guess it's not really a question, but Adrian says governance is one of the tips of the spears of blockchain potential, but it doesn't get much attention. Real world problems should make it obvious. I guess that's just commentary. Thanks, Adrian. So yeah, very powerful stuff that we just talked about today. Thank you, Ethan and Martin, for coming on the show. Are there any last comments that you guys want to make before we sign off?
Just to say thank you very much for hosting us.
Absolutely. And where can people find you on socials so that they could follow up on this project?
On Twitter, on Tgrade Finance, we have a Telegram group, and we're on Discord as well.
And for CosmWasm, there's Medium, CosmWasm on Medium and on Twitter. And yeah, there's a lot of articles. You can follow me, Ethan Fry, on Medium too. I don't use Twitter, but I do. Most of the articles go on CosmWasm Medium anyway. But yeah, I'm very happy for that. And I'm on Discord. Look for the CosmWasm Discord. I'm there, and I'd love to talk about things like IBC. If you want to talk about IBC and DAOs, I'd love to chat with you in there.
Yep. Yeah, I love the concept of DAOs right now, which is what we're doing is we're experimenting with private DAOs, and eventually I hope we can disrupt the existing, the biggest DAOs in the world, which is the federal governments of each nation. So if we are able to privatize public goods funding and actually be efficient with our money, well, we'd relegate the federal government to obsolescence. And that's the goal, right? Okay, with that note, thanks for tuning in to Interchain FM. We're doing these interviews every single Thursday here on Twitter and YouTube Live. So next week, we're going to talk to Brent from UMI. UMI is the lending and borrowing protocol in Cosmos that we kind of alluded to earlier in this episode. We're going to be able to do stuff like collateralizing Cosmos native assets and then borrowing ERC20s basically and doing DeFi stuff on Ethereum and vice versa between the two ecosystems with UMI. So very exciting stuff coming up in the next week. You won't want to miss it. And until then, happy Thanksgiving, guys. Thanks for tuning in and bye.
Bye.